Hello and welcome everyone. I hope you can see me and hear me. Attila Kovacs is with us. Unfortunately, the camera doesn't work, but the PowerPoint presentation does work. So Attila Kovacs, let me introduce himself shortly. He's a professor, researcher, author, and with deep expertise in test design and software quality. Today's session title is Test Design Automation, Unlocking the Future of Domain Testing. So we will start with the poll again. Just let me publish it. I hope you can see it. Where do you see the greatest opportunity for test design automation? In reducing repetitive design tasks, in handling domain complexity with models, in scaling test suites efficiently, in improving collaboration between roles. So I want to see your participation.
So thank you very much, and
Yes.
welcome everybody.
Attila, I will give you the word after the poll is ended, just
Okay.
in 6 seconds, and then you can start. Is
Okay.
it okay? Okay, perfect. So, yes, I can see the most answer is in reducing repetitive design tasks. Okay, thank you for the participation. So let's begin with the presentation. Over to you, Attila. You can start.
Thank you very much. Thank you, and welcome everybody. My name is Attila Kovács. I am from Hungary. And the title of my short talk today is Test Design Automation: Unlocking the Future of Domain Testing. Few words about me. I am the founder of the Hungarian Testing Board. I wrote several books, including test design books. You can see in a picture. Modern software testing techniques, paradigm shifting software testing, and practical test design. I'm initiator of the website testdesign.org. I'm explorer of test design techniques, action state testing, reliable domain testing, the target today, and combinative testing. I'm full professor at the biggest university in Hungary, and I have enough experience. So I think, let's start. First of all, I want to speak a bit about the importance of test design. Suppose that we are living in an ideal world, no wars, no diseases, no bugs. Unfortunately, the reality is different. Only in the last year, poor software quality in the US cost the economy at least $2.4 trillion. A major tech outage in July 2024 disrupted banks, airlines, and cloud services, causing millions of dollars in economic losses. The outage traces back to poorly managed software dependencies and vulnerabilities, impacted various sectors, including banking, healthcare, and transportation. The financial impact of the outage alone was estimated to be $3 billion. So we have challenges. Unfortunately, accurate planning, scheduling, continuous collaboration, efficient tools, automated regression testing, well-organized lifecycle, optimal test environment, future-oriented documentation are necessary, but not enough. It's not enough to be efficient. Testing needs to be effective. So one of the biggest points today to understand that test design plays a greater role in preventing bugs than the act of testing itself. So why test design is so important? Test design prompts deep analysis of requirements, often uncovering ambiguities, inconsistencies, and missing functionality early. It drives clarification with stakeholders, leading to better requirements and fewer errors. By exploring edge cases and negative scenarios, it improves code quality and prevents bugs before development begins. Test design concentrates to defect prevention that is always cheaper than defect detection. Few words about test design manifesto. Please use justified test design methodologies over ad hoc methodologies. We need to use combined techniques over single technique. And regarding the efficiency, we try to find linear techniques over nonlinear techniques regarding the number of test cases, Considering the risk analysis, cost and quality optimized test design should be performed always. Automation. Of course, we want to use automated test design instead of manual techniques. And don't forget, please, to harmonize the academic and industrial results and incorporate into the testing. So just one definition, I promise. Test design technique is a procedure for determining test conditions, test cases, and test data during the whole software testing process. Test design techniques. We have static and dynamic type of test design techniques. Regarding the dynamic part, we have experience-based, structure-based, and specification-based, other words in black box. In black box case, the tests are designed by the specification. Here we can have different targets, targeting the efficiency, performance testing, targeting the test oracle, metamorphic testing, targeting the action sequences, action state testing or state-based testing, targeting the input domain, called domain testing. We deal with domain testing today, or targeting the combinations, diff pair, pairwise, or others. So we concentrate now to the domain testing, especially reliable domain testing. Originally, domain testing was figured out to the code, to the white box side. Before the rise of ChatGPT, the present specification-based method was called GPT, General Predicate Testing. It's just for joke. Based on the author's suggestion, ISTQB CTFL incorporated the technique for single variables as 4-point BVA in the newest syllabus. And domain testing is part of the newest ISTQB advanced level syllabus as well. So what is domain analysis testing? It's reliable, automatable, cheap, and enhanced technique. I explain it. In case of linear predicate systems with less than 3 variables, the technique reveals 100% of bugs. Again, the technique able to reveal all the bugs, which is mathematically proven. This is the only test design technique that able to unfold all the specific bugs. And I have a good news that over 99% of the predicates fall into this category. I mean, linear with less than 3 variables. Automatable. What we have now, that given written requirements, we are able to generate with AI, with a large language model, a domain model, with a general predicate testing tool, able to generate a test data. Based on the test data and a different AI, again, different LLM, we can generate the expected outcome. And then we have the test cases, first the abstract one, then we can go further to the concrete test cases by which we can verify the software. That is the life cycle which can be full automated. Domain testing is cheap. It means that the resulting test set size is linear in the number of predicates. Of course, I will show you several examples for this point. It's quite important. The small test set size supports cheap regression testing. We don't need for combinatorial one. However, to tell the truth, the optimization part behind the domain testing is quite hard. It's called mathematically NP-complete. But in practice, we don't have thousands of variables in one single predicate system. In practice, the running time was always measured by milliseconds. ChatGPT and DeepSeek were used as LLM, showing quite nice characteristics. However, we need to know that at present, it's not scalable to large requirement descriptions, which means that when we have several hundred pages of requirements, the AI is unable to generate the model and the expected outcome. However, for few pages, it works perfectly. Enhanced, what does it mean? It means that the model, that the domain analysis testing generalizes the old techniques, equivalence partitioning, the boundary value analysis, 2, 3, 4-point BVAs, decision tables, classification trees. And the optimization eliminates the need for combinatorial methods. So the linearity, again, quite important now. So I think we are in time to see some examples. The first example, quite simple. The requirement description can be seen here. The system shall continuously monitor the following 6 parameters and ensure each remains within its defined safe operating range. If any parameter exceeds its allowable limits, then the system must immediately trigger an emergency stop procedure. You see here the 6 parameters: temperature, pressure, voltage, current, humidity, and speed, and you can see the given ranges. Now the developer produces a solution in any programming language, and the tester task is to verify its correctness. When we apply the 3-point BVA, which is not reliable, we have plenty of test cases. Even when we apply the 4-point BVA, it requires 48 test cases, quite much. Domain testing, on the other hand, results in just 26 test cases. You can see the test cases and you can check home. My second example, a bit more complicated, is a roller coaster. Scenario is the following. The system under test is responsible for controlling passenger entry and initiating the ride cycle of a roller coaster. Entry decisions are based on evaluation of 3 input parameters: passenger height, it's an integer value in centimeters, total passenger weight, integer value as well in kilograms, and the number of available seats. The system processes these inputs to determine whether to grant access to the ride. A bit more in detail, the first requirement, the passenger height is categorized into 3 groups for anti-control. Basically, children shorter than 120 centimeters are denied access. Small people having height between 120 and 140 centimeters inclusive are permitted entry only with a seat extender. And individuals taller than 140 centimeters are granted to the ride. Next requirement, if all seats are occupied, then entry gate closes and additional passengers must wait for the next ride cycle. Clear. And the last requirement, when a visitor attempts to enter and the addition causes the total weight to exceed 1,000 kilograms, they must remain outside and the gate closes. So it's overweighted. once the gate is closed, the ride can start if the total weight of the passengers is between 700 kilogram and 1,000 kilogram. However, if the total weight is below 700 kilogram, additional weight blocks are added before the ride begins. That's the free requirement what we have. And let's solve it with traditional solutions and compare it with domain testing. Maybe the easiest way solving the problem with classification tree. We have a roller coaster having 3 parameters: height, total weight, and the number of free seats. The height can be categorized, you can see it below 120, between 120 and 140, and over 140. Total weight, again, can be characterized in 3 classes, and the number of free seats, basically the last place are there or there are enough places. That's all. And now, depending on what kind of combinatorial strategy we want to combine, we want to use to combine the values, I computed it and I shared the result. When we are using the good old base choice, which is linear, then we have 7 test cases. Unfortunately, it's not reliable. When we are using the diff pair strategy, still linear, then we have 8 test cases. Again, it's non-reliable. When we are using the pairwise strategy for combinations, which is quadratic, then we have 9 test cases, and still it's not non-reliable. When we are using the 3-point BVA, so for the combinations, which is of course exponential number of test cases resulted in, then we have 72 test cases, and again, it's non-reliable. However, when we use the 4-point BVA for the combinations, again, it's exponential, resulted in 128 test cases, but it's reliable. In domain testing, we have just 32 test cases, which is, again, it's linear strategy and it's reliable, just for comparison. So domain testing is far the best solution for the others. And the time needed to apply the model is the same, not more, even a bit shorter. Solving the problem with decision table. You can see the decision table here, free conditions, height, total weight, and number of free seats, and you can see the actions depending on the different parameter values. It's a correct decision table. We can check it at home. You can follow, but the result is even more important now. When for one column here, we are using the 3-point BVA for test case design, then it resulted in 51 test cases, which is non-reliable. When we are using the 4-point BVA, we have 68 test cases. However, in domain testing, we have just 32, less than a half for such a simple example. Domain testing with architecture decomposition. We know that the present domain testing method is a white box method. However, what happened when we go to the we whitening the black box to gray box and white box. Just an example here, suppose that we know the following decomposition. So we know basically how it will be programmed. Then, in that case, the domain testing requires just 19 test cases. So it means that, again, the next point which we should understand and bring home, please, that proper functional decomposition may drastically reduce the number of reliable tests. the black box and the white box methods can be combined in a CI/CD pipeline. So we have something which cover a black box strategy, and when we know something more, we know the architecture, and we solve for the pieces, and we add them together, I mean the test cases together, still we have a big advantage. We can reduce the number of reliable tests. Basically, I'm at the point for the summary, and then hopefully we can discuss the things more in detail. So the first, domain testing, the black box domain testing, is reliable, automatable, cheap, and enhanced for revealing any predicate fault. The only strategy. The usage of domain testing in safety-critical systems, I think, is obligatory because of the 100% of bug revealing capability. Whitening the black box test design towards test generation with proper functional decomposition may reduce the number of test cases drastically. So I wanted to show you that domain analysis testing is a very strong form of test design, generalization of the all other test design strategies, having linear number of test cases, which is very good for us, and again, having 100% bug revealing capability. And basically, that's all I wanted to share with you, maybe a bit short, but probably we can now discuss, and I try to answer your questions. So I want to read your questions and I try to answer them.
Thank you, Attila, so much for this beautiful presentation. And it was on point. It was enlightening for us. So for the audience, please use Q&A part for your questions, if you have.
Just one remark, maybe it's important.
Yeah, sure.
Because the audience may be interested in where can they learn how can be used.
Yes,
and it is described here in the first book, The Modern Software Testing Techniques. Everything is described here. Many examples, and mathematical proofs are there. So to show how can use this model and why it is so brilliant. You can read it in the first book, again, Modern Software Testing Techniques.
Modern Software Testing Techniques by...
the author is me, and my co-author István Forgács, and you can buy it in Amazon or everywhere.
Yes.
It's issued by the A-Press, Berkeley, California.
Thank you. I wrote it on the chat part for people to see clearly. Okay. Thank you, Attila, for being a part of Live to Test. That was a fantastic session. So thank you for sharing your knowledge and experience with us. Huge thanks for your contribution. I hope you also enjoyed it.
Yeah, thank you very much.
Okay, so we have a question if you would like to ask. Taner asks, what are your thoughts and practices on the use of AI in automation?
Yes, as I mentioned, we were used the large language models for generating the design model and for generating the expected outcome. That's from my side. And hopefully the next speaker will answer other questions, but using the AI again. Thank you.
Thank you so much, and see you again in the other sessions as an attendee. I hope so, and hope you have a great day. And also we have another question now, and let me show that on the stage. How do you deal with redundancy when automating tests from decision tables?
Very nice question.
Yeah.
Basically, when we want to use decision tables, then especially me, start from a special cause and effect graph, and I generate the decision table. In that way, it will be reduced and correct. So I start always with the cause and effect graphing strategies. I have my own tool for that. So that's the thing. And when we have a decision table, we can, so the automatic process reads the columns from decision table, put to the tool of the GPT, general predicate testing tool, and generates the input. And it's quite important to mention that everything is available. The tool is freely available in the testdesign.org website. You can find several examples there. You can check your knowledge because in real life, because there are several examples and it's mutated. We put bugs into the examples and you can check yourself, check your knowledge, how many bugs you are able to find. But the tool is available there, so you can use it. Just one page short description. So it's quite simple and quite easy to use.
Okay, thank you so much. And another question appears, and from Özgeaydın, in your experience, where do manually designed tests outperform generated ones in domain testing?
Manually designed tests outperform generated ones. Domain testing is the only test design technique which is able to reveal all the bugs, all the predicate bugs. I think using the tool is always cheaper and don't miss anything. So I don't think that manually it takes time, especially again, imagine that the tool generates, 30 test points. Then you need to compute the expected outcome for those points. However, AI can help, of course. Again, it's automation. Otherwise, when you don't have such an AI solution, then of course, yes, manually, which takes time, I know. So again, all the parts, the mentioned domain testing strategy can be done by hand as well, but it's too slow. Not slower than the decision tables or whatever, but the same approximately in hand.
Thank you so much for answering all of the questions. Thank you for your time. Thank you for your contribution, Atilla. Hope you have enjoyed also. And have a great day.
Thank you for you as well. And thanks for coming to the audience.
Thank you. Thank you. Bye-bye.
Thank you. Bye.
Okay, so now we have like a 15 minutes break, a coffee break, and then we will move on with our first tutorial session from Altuğ Bilgin Altıntaş, Elevate Your Testing Strategy and Introduction to Mutation Testing. We will start in 15 minutes. So grab your coffee, grab your tea, grab your snacks, and see you there in 15 minutes. Bye-bye.